Okay, we are on page 46 now, which is the page after 45. And I realize you know that, but some of you, your notebooks are still a hot mess. We are talking today about volume. Woohoo! And good news, out of all the geometric figures we've been messing around with, the only one that you are responsible for knowing how to find the volume is rectangular prisms. Which, to remind you, is a figure that has two identical bases, which are rectangles, and is looking something like this. Could be long and skinny, but this is the basic gist of it. Now, volume is how much room something takes up, or the room that's inside of something. So the volume of your bathtub is how much water it can hold. But you also will see volume to mean, like, if you have really fine hair that just sort of lays there, and you use a shampoo that promises to increase volume. Okay, this is going to be my really quick drawing of a shampoo bottle. And you use that shampoo and it turns out to really work, your hair is going to take up more room than it took up before. Okay? So volume is the amount of room something can take up and the amount that it can hold. You are probably very familiar with the idea of volume. So one way to find the amount of volume this could hold would be to pack it with unit cubes. So one method is to pack with unit cubes. It's called a unit cube. It's called a unit because whatever the unit is, centimeters, inches, feet, it is one of that in every single way that it can be. So a 1 centimeter cube would be 1 centimeter by 1 centimeter by 1 centimeter, 1 centimeter, 1. All of these would be 1. If it was an inch cube, it would be a little bit bigger because 1 inch is bigger than 1 centimeter. But again, it would be an inch in every possible way. So it's called a unit cube because whatever the unit is, it's one of it. And it's called a cube because all the sides are the same square. Okay, so that is a method, is to pack. I could take this and I could pack it with unit cubes and see how many cubes fit in there. Let's say 58 cubes fit in here. That would tell me if each cube was 1 cubic inch and 58 cubic inches fit in here, then the volume is 58 cubic inches. Okay, however, that is not very practical in most cases, and so we have come up with another way, a different method, and that is to calculate the volume. So if you imagine for a second, maybe thinking of it like a net, if you looked at this square and you had unit cubes, you would say, all right, I know that I could get, let's say, 6 across and 6 across. So 6 times 6 would mean I could set 32 squares on this. But now I need to know how many layers of 36 cubes could I have. Let's say that this is 4 inches. I could have 4 layers of 36 cubes, which means 4 times 36 is 134. I want to say 134. 144. There we go. 144 unit cubes. We can replicate that by taking the length of the square or the rectangle. So we can take the length, we can take the width, keeping in mind this is what would form the rectangles that we're used to finding the area of. And then we multiply it by the height. And when we do length times width times height, we get V for volume. I know you've done this before. What may be new to you this year is that in 6th grade, we expect that we can throw in fractions and you can still roll with it. So let's say that this is 3/4 of an inch long by 7/8 inch wide by 1/2 inch tall. So we expect that you can go, okay, the length is 3/4 times the width is 7/8 times the height is 1/2. 3 times 7 is 21, 21 times 1 is 21, 4 times 8 is 32, 32 times 2 is 64. Now I look for common factors. Well, they do not have any common factors. So that's simplest form. So 21/64 cubic inches. Volume is always in cubic inches, right? So area, we were finding squares. Volume, we're finding cubes. Now you might be wondering, how is that possible? Well, think about that each side was less than 1 inch. So it was not going to be possible for it to be a whole inch cubed. So it makes sense that when we multiply by fractions, when they're less than 1, we should expect, even though it seems funny, for our final volume to get smaller. So, finding the volume of a rectangular prism.